Assalamualaikum, my name is Muhammad Zahri Ikhwan bin Muhammad Zubair. My matrix number is CN170021. So today I will present about my project, and the title is Alternative Soundproof Material to Reduce Noise HVAC Round Duct System. So my supervisor for this project is Encik Wan Muhammad Wardi bin Wan Abdul Rahman. I am from Department of Mechanical Engineering Technology and Faculty of Engineering Technology. Okay, I will go for abstract first. Rockwool is one of the synthetic fiber that widely used to overcome noise problem in beauty industry, especially to minimize breakout noise in HVAC system. However, this fiber is categorized as non-biodegradable material and contribute to global warming due to carbon dioxide emission. The purpose of this study is to investigate acoustic properties of rockwool and bamboo fiber, which the type for bamboo fiber is Burton bamboo, or known as Dendrocalamus asper for its scientific name. I use this bamboo fiber as a new material or alternative material for sound insulation. Okay, so there are two acoustic parameters that we will measure in this study. Okay, first, sound absorption coefficient, and the second one is sound transmission loss. The bamboo fiber of two different thickness, which are 25 mm and 50 mm, with density of 60 kg per meter cube and 120 kg per meter cube respectively, while the rockwool is also two different thickness, 25 mm and 55 mm, but with same density of 40 kg per meter cube. We are tested in this study. Okay, after the test were done, the results shows that bamboo fiber is more superior performance in sound absorption coefficient and sound transmission loss compared to rockwool. Okay, the maximum for sound absorption coefficient is obtained by 50 tick of bamboo fiber, which is 0.99 at frequencies of 1250 Hz, 1350 Hz, and 4000 Hz. Okay, the sound transmission loss also obtained by 50 tick of bamboo fiber, which is 0.27 at 4000 Hz. In conclusion, the bamboo fiber is highly potential to be used as raw material for sound insulation in order to replace synthetic materials. Introduction. Okay, HVAC is used to comfort occupants in building. The mission of HVAC is depends on outside condition of the building. If the outside is hot, then the air in the building needs to be cool, so to achieve thermal comfort. Basically in Malaysia is hot, so that's mean we need to cool the air before distribute into the building. Unfortunately, the involvement of HVAC is in the building produce a noise problem, so that's mean we need to counter the noise to achieve acceptable noise in the building. Okay, the main target of the result for this study is to overcoming the previous noise problem by applying the external sound insulation on the air duct. Okay, this study is focusing on finding the alternative soundproof material that should be able to replace previous soundproof material, which are rockwool and glass fiber. It is because this previous soundproof material have bad impact for our health and environment. Okay, the types of material that we have tested during this research are rockwool and bio-based material, which is bamboo fiber. Okay, so this study aims to investigate performance of bamboo fiber as a new sound insulation material to be applied in HVAC system. Now objective section. Okay, basically this study have three objectives. First, to minimize the breakout noise that produced by air duct in HVAC system by using natural soundproof material. Second objective is to investigate the sound absorption coefficient and sound transmission loss of rockwool and bamboo fiber. For the third objective is to compare the ability of rockwool and bamboo fiber as soundproof material. Literature review. Okay, according to hvac, air duct are used in HVAC system to deliver air into occupied space, but this air duct produce breakout noise. So to overcome this noise, we should apply the exterior sound insulation on the air duct. Okay, next, Asdur Bali report that rockwool is widely used in building industry for sound and thermal insulation. However, this fiber is very dangerous to environment because it releases a lot of carbon dioxide that lead to global warming. So basically, this fiber also hazardous to human health if it was inhaled and exposed to the skin. Next, Ziyadon Zhu report that bamboo fiber has lower impact on environment than synthetic fiber, and it also good in sound absorption. Another research on bamboo fiber by Takayaki Koizumi, he mentioned that bamboo fiber has a good sound absorption and has acoustical properties equivalent to those glass wood. Okay, now we go for the methodology. Basically, this study has three steps for the methodology. Okay, first, material preparation. Next, measurement methods. And the last one is comparison session. Okay, for the bamboo fiber preparation, the species for the bamboo that used in this study is betung bamboo, or known as Dendrocalamus asper for its scientific name. I bought the bamboo from local at Terengganu. So basically, this bamboo need to do the extraction process to turn the bamboo into the bamboo fiber. So the process for the extraction begin with soak the bamboo into mixture of water and sodium hydroxide for 1 day or 2 days to make the bamboo become soft. After that, dry the bamboo fiber under the hot sun to remove its moisture. Okay, after remove its moisture, I use a hot press under 180 Celsius and pressure is 1000 psi to turn bamboo fiber into two different thickness, which are 25 millimeter and 50 millimeter. After that, I weigh the bamboo fiber to determine for their density. So this is example samples that to show you that fine diameter of bamboo fiber. You can see this is bamboo fiber after the hot press. Okay, for the rockwool, I just bought it on market with a thickness of 50 mm and 25 mm, and the density for both thickness is 40 kilogram over meter cube. So this is rockwool. Okay, next I will explain for the measurement methods. Okay, in this study, there are two measurement methods that used in this study. First, sound absorption coefficient, and the second one is sound transmission loss. Okay, for the measurement of sound absorption coefficient, I use impedance tube according to ISO 10534. This tube divide into two a different diameter, which are 28 millimeter, and the second one is 100 millimeter. So basically the frequency range also divide into two groups, which are low frequency and high frequency. So for the 28 millimeter round tube, it's for high frequency range from 2000 hertz to 6000 hertz, and for 100 millimeter round tube is for low frequency range from 150 hertz to 1150 hertz. 1550 hertz. For the sound transmission loss, I use 1/3 octave band, and the frequency range is 125 hertz to 4000 hertz according to ISO 1403. So this measurement is carried out in reverberation room. Okay, the last step for the methodology is a comparison session. Okay, so this section is to compare the ability of rockwool and bamboo fiber as a soundproof material. Basically, to determine which better to be used in HVAC system in order to reduce the noise. Okay, for the result and discussion, first I will explain for sound absorption coefficient. Okay, as you can see in the figure, the uncontinuous blue line is for 25 millimeter thick of bamboo fiber, and the uncontinuous red line is for rockwool that has 25 millimeter thick. For the continuous red line is for 50 millimeter of rockwool, and the continuous blue line is for 50 millimeter thick of bamboo. Okay, the results show the sound absorption coefficient between rockwool and bamboo fiber that having same thickness of 25 millimeter, almost same at low frequency region. The maximum that obtained by 25 millimeter of bamboo fiber is 0.53 at frequency of 1550 Hz, while the maximum sound absorption coefficient for rockwool is 0.51 at frequency of 1550 Hz. Okay, the result for 50 millimeter thickness of rockwool and bamboo fiber show different value of sound absorption coefficient at low frequency region. However, the sound absorption coefficient of bamboo fiber is more higher than sound absorption coefficient of rockwool. The maximum that achieved by bamboo fiber is 0.99 at frequency of 1250 Hz and 1350 Hz. But when reaching the frequency of 1550 Hz, the sound absorption coefficient for both samples are having same value, which is 0.98. Okay, at the high frequency region, the result of sound absorption coefficient show that 25 millimeter of rockwool is more greater than 25 millimeter of bamboo fiber. But when reaching the 3000 Hz frequency, both material showing decrements up until 6000 Hz. Okay, for the 50 millimeter thick of rockwool, the value for sound absorption coefficient is more higher than sound absorption coefficient of bamboo fiber at frequency range between 2000 Hz until 3650 Hz. But when after reaching frequency of 3655. The sound absorption coefficient of bamboo fiber is more higher than um, rockwool. The maximum that achieved by bamboo fiber is 0.99 at frequency of 4000 Hz. Now I will explain for the sound transmission loss result. Okay, so the result for sound transmission loss of 25 thick of bamboo fiber is slightly higher than 25 millimeter of rockwool. So the maximum for sound transmission loss of bamboo fiber is 36 dB, while the maximum for sound transmission loss of rockwool is 35 dB. Okay, for the 50 millimeter thickness of rockwool and bamboo fiber, the sound transmission loss value of bamboo fiber is more higher than sound transmission loss of rockwool. So the maximum for the sound transmission loss of bamboo is 72 dB, while the maximum value for sound transmission loss of rockwool is 70 dB at the frequency of 4000 Hz. Okay, in conclusion, this study has proven that bamboo fiber is a good material in sound absorption coefficient and sound transmission loss if compared to rockwool. So basically, the maximum that obtained by 50 millimeter thickness of bamboo fiber for sound absorption coefficient value is 0.99 at frequency of 1250 Hz, 1350 Hz, and 4000 Hz, while the sound transmission loss value is 72 dB at 4000 Hz. In conclusion, the physical factors that affect the value for sound transmission loss and sound absorption coefficient is the thickness and density. This study also proved that bamboo fiber is good in acoustical properties equivalent to those rockwool, so which is a good sound absorber material. Okay, based on the positive performance of bamboo fiber, we can use the bamboo fiber as a new material for sound insulation in hvac system to replace the rockwool and glass wool. So this is the reference that I use. Okay, so that's all from me. Thank you.